Picking up right where we left off on last video, now part B wants us to find the cubic function that best fits the data. We are going to report the model with not 4 decimal places, but 4 significant digits. So we also went over significant digits in module 2 when we were doing quadratic regressions. So if you need to rewatch that video, please rewatch that video talking about significant digits. Okay, so now we're following these steps here, and because it tells me specifically that it wants a cubic function, I want to hit number 6 here. So picking up right where we left off, we still have that scatter plot here. So now I'm going to go to stat. I need to arrow over here to calc. And now we will go down here to number 6. You can either punch in 6 or arrow down and hit enter. Now, typically we have just went through this and just went straight to calculate, but because my instructions later on want me to graph these functions on the same axis, I'm going to go ahead and store these into my graphing feature. So I'm going to use these optional steps here. So I'm going to arrow down to the store reg EQ. And so what that stands for is we're going to store the regression equation. So I want to go to F4, which you can see is right here in green. So we need to hit alpha trace. And I want to store this into Y1. So I'm going to hit enter since that's right there. And now I will go down to calculate, and here is my calculation. So I'm going to do this and just go ahead and put this right into my equation. My equation is right up here. So we have y equals ax cubed plus bx squared plus cx plus d. And let's write this into the equation as we go, because I don't have room to write, a equals b equals c equals d equals. So my a rounded to 4 significant digits means these first 2 zeros do not count. So here is my first significant digit, my second, my third, my fourth. So I'm going to look at that 5th significant digit, and that 5 makes that 3 go up. So this is 0.00188, and that's in front of my x cubed. So even though it says 4 significant digits, we have 6 decimal places here. Okay, then I'm going to look at my b, and my b is negative, so I have a minus. This first 0 does not count. So then we have 9, 5, 3. So this is my first, second, and third significant digit. My 4th significant digit is at 8, and that 3 makes that 8 stay. And that is x squared. My c is positive, so plus. That 2 is my first significant digit. So 2, 7, 8 is first, second, third significant. Looking at that second 6 makes that first 6 go up to a 7. And that is cx. And then plus d, but my d is negative. So again, 2.7, that is 1, 2 significant digits. 0, 0 is 3 and 4, but that 8 makes that 0 go up. So 0, 1. Okay, there is my cubic function. Now part C wants my quartic function. Okay, and again, rounded to 4 significant digits. So let's go through these same steps, but now instead of 6, we're going to go to 7. So I'm going to go stat, arrow over to calc, either punch in 7 or arrow down, but we want this court regression. And I want to store this again. Now, let me kind of show you what we did before. If I go to y equals, I stored my cubic regression in here with all of those digits here. So I don't want to restore this into y1. I now want to store this next one into y2. So let's keep that in mind. So I'm going to come down here to where am I going to store my regression equation? Go to alpha trace. And now I want to store this into my y2. I don't want to rewrite it over my y1. I want to put the new equation in my second spot. So hit enter, and now we are calculating. Now, because this one is so long, it does not show you that full equation. If you need to go back to module 4, lesson 1, where I write out that, you can, but it's just A is with your x to the 4th, B is with your x cubed, so keep going. C is with x squared, D is with x, and then E is your constant. So my equation is y equals ax to the 4th plus bx cubed plus cx squared plus dx plus e. It's a, b, c, d, e, and then x to the 4th, 3rd, 2nd, 1st, none. Okay, now this one's a very long one, so I'm going to come way over here. And right from the get-go, we've got to be careful here. We have our a equals 2.34 and some more digits, but notice as you get down over here, this is e to the negative 5. This right here is in scientific notation. Okay, so if I, what do I want to do here? If I write this over here, we have let me go even further. We have 2.340237.9. And let me start over again. That's not big enough for me. Okay, there's my number that they give me here. That e to the negative 5 is scientific notation, meaning times 10 to the negative 5. So I first need to put this into standard form so I can then round to 4 significant digits. So if this is times 10 to the negative 5, to put this into standard form, I'm going to take this decimal and I'm going to move it 1, 2, 3, 4, 5 units over. So in place of all of these that don't have numbers, we get zeros. So now when I'm rounding to my 4 significant digits, these 4 zeros do not count. This is my first significant digit, my second significant digit, third, and fourth. So we're looking at that 2 right there. So this would become 0.000, none of those count, 2, 3, 4, and then that 2 is going to make that 0 stay. So you can write it just like this, or you can have a 0 behind, but we don't really need that 0 there. Okay, so that is my first number here for this A. Okay, keeping going. Then we have minus B. So those first 2 zeros do not count. And then we have 1 significant, 2 significant, 3, and then this 7 makes this 6 go up to a 7. And that is x cubed. My C, that first 0 does not count. So 1, 2, 3, 4 significant. This 4 makes this 4 stay. Plus 0.0784 x squared. D, we have 1, 2, 3, 4 significant digits. This 3 makes the 6 stay. And then for my E, 1, 2, 3, 4, again, that 4 makes that 4 stay. So plus 12.64. Ooh, okay. Let's go over part D, and then we will make a new video for E and F. So part D says graph each of these functions on the same axis as the data points and visually determine which model is a best fit for the data. Okay, we can go about this one of two ways. Now that I have stored in my equations, and they are exact, right? Every decimal, not using these quote models, using the entire thing. Now I'm going to hit graph and I'm going to see which one of these is a better fit. Now it tells you specifically to do them at the same time, but it's kind of hard to tell when you do them at the same time. So here they are together, and it really looks like they're both on top of each other. Like there's not much of a difference, right? Well, let's just kind of do one at a time and see if it helps. So I'm going to come over here and I'm going to unhighlight that equals, and that means it's not going to graph my Y2. So now when I hit graph, you can see here it hits pretty close to all of your data points. It's a little off on this one. It's a little off on these two. It's a little off on this first one. So it's maybe off on about 4 of them. Let's compare that to the other one. So now I'm going to unhighlight that equals and highlight this one. So now it's going to graph my Y2. And you can see there, it is pretty much hitting every single one of those. So for part D, we will say our quartic function is the best fit. Why? It hits all points. Now, if you don't want to do it that way, just compare your R or your R squares. And even though we didn't write those down, we can easily go back and get those. If I arrow up, here's my quartic regression. Hit enter, and I can get all of that information again. So here is my R squared here. Let me write this in a different color. My R squared is about 0.999. How many nines? 1, 2, 3, 4, 9. And then that 5 would make that 7 go up. So we're going to say 9.8. Okay, that's insanely close to 1. If I go second mode to quit, now I'm going to arrow up until I get to my cubic regression. Hit enter, and I can get that data all over again. So don't go back through the steps. Just arrow up in your history and find your information. And here, my R squared is about 0.999. That 5 will make that 4 go up to a 5. But when you compare those R squareds to each other, you can see that this is much closer, right? You've got 9, 9, 9, but then 9 is closer to 1 than that 5 is right there. So you can use your R squared to compare if you don't want to use the graph right here.